Hello everyone, this is Mohammed. Welcome to my YouTube channel, and this video is going to be a slightly different to the usual video that I create regularly. In this video I am going to discuss one of my past videos. Why? Because generally I don't get many comments to my video, and not many visits as well either. But in this particular video, which is talking about weekly challenge 75 task 1, which is called someone recently commented in my video saying, could you please output the combinations in matrix form? Thanks in advance. So I thought, okay, let's revisit it. It's been a long time. I've only recently started making video again. So I had to recap everything and try to understand what I've done and what is missing that this user is asking me to do. So in this video I'm going to try to answer the question that this particular user has raised. So let me go back to my playground. So this is this is the existing code, excuse me. And if I run the code as it is, so it says for the default coins 1, 2 and 4, and to achieve the total sum of 6, that 6 different ways you can achieve. So what I understood from the user saying he actually interested in to know the different combinations and not just the count is what he's after. So first thing first, I wanted to find out again. First thing, because in the existing solution I'm creating a matrix by using this dynamic programming concept that I found out on the internet. So I thought, okay, let's figure out how the matrix looks like in the end, and then probably we can take it from there. So first thing I'm going to do is I'm going to just create a method which would display the matrix that I have. So let's create a subroutine for that. So let's call it show matrix. And I'm going to pass the matrix and that. So this matrix is going to pass, and then I'll just run through. So the rows is going to be at dollar matrix is my number of rows, and my columns is going to be the element in the first row. So it's going to be dollar matrix. So whatever elements, number of elements in the first row is my number of columns in the matrix. And just loop through each row and columns. Start from 0 dot dot rows -1 for each my $C 0 dot dot calls -1. You know why I'm doing -1? Because it's a zero index array. And yes, and then what I'm going to do is I'll just print the value. So I'm going to do is print of percentage s space and just matrix row column. So that's my matrix, and once I print the entire row, I'll just put a new line, so the next line is going to start. So that is my show matrix. So what I'm going to do is, before I return the result, I'm going to call this method that will print the matrix for me. I pass the matrix to this function. Let's see, what do we get? Did I miss something? Where's the top here? I need the closing brace, correct? Okay, so I do see matrix here, but there is something not correct, which is line number 58. So it looks like one of the cell is not defined or has got undef value. What is wrong here? Let me figure it out. Maybe we're not creating the matrix in the correct form, so probably so this is my matrix initialization, and then I'm putting 1 into the first column of each row, and then I'm filling up the remaining column. Hang on, one thing, this is wrong. Why I'm doing +1? Don't need to do +1, so let's get rid of this +1. That's wrong. So save it and then run again. Right, so that was the error in my existing solution. So this is the only change I made to my existing subroutine coin sum. So as of now, I still don't get the number of different combination. It's still showing me the count, not the different combination. But at least I see the matrix it's using to get this number 6. And what this number means is basically saying across the column is the coin sum. So starting with 0, 1, 2, 3, 4, 5, 6, and the row is the coin, and the coin is, I believe, for the coins is 1, 2, 4. So this row belongs to the coin 1, this row belongs to the coin 2, and this row belongs to the coin 4. So what they're saying, using 1, 2, and 4 coins, and to get the total sum of 6, you have a 6 ways, different ways of doing. But this number shows how many different ways to get that sum. So if we say this is sum 5, so using 1, 2, and 4, there are only 4 ways you can get the total values 5. Similarly, so these are this count is only shows the different ways you can get it. But I assume the user wanted to find out what are the different ways, different combination you get to make it 6. So let's try to solve that question. So what I'm going to do is, so for this I am proposing a slightly different approach to get to the solution. So what I'm going to do, I'll keep the existing one. I'll call it underscore, so I don't change the code, the functionality of existing solution. So let's call the new method coin sum, and same thing. I'm expecting the total coins and the sum that I'm after. Okay. So what is the new approach I'm proposing? So let's put some comment here. So I'm going to use a similar kind of matrix where the column represent the coin sum starting from 0. So in this case it's 0, 1, 2, 3, 4, 5, 6, and across the row is the coin, so it's going to be 1, 2, and 4. That's how I'm going to approach. So let's create a placeholder which will hold the combinations that I'm after. So I'll call it combinations, and I'm going to create a reference to a hash, so it's easier. So let's call it reference to a hash, which is combinations. And I'm going to go through each coins one by one. I'll use the coin in the sorted order. So at dollar coins. So go through one by one coin in sorted order. Yeah, and then I'll go through, because that's the row and the column is the sum starting from 0 to the sum I'm after. But in this case I'm only interested in the column where it starts from the current coin value. So what I'm going to do is, for each my sum is going to be $C, which is the current coin value. If in case of 1, it's going to start with 1 till 7. In case of coin 2, it's going to start from 2 to 6, and in case of 4, it will start from 4 to 6, and then it will go up to 7. And yes, the idea of the new approach is going to be, so for example, let's count down. So it's going to be 0. For the given example, I'm using 0, 1, 2, 3, 4, 5, 6, and the coin is going to be 1, 2, and 4. Yeah. So this is the matrix and the array, two-dimensional array. I'm using. So okay, so because of as I use the other method, the first column of each row is going to be 1 by default. So we'll just put 1 in there. So it's 1, and as I said, we're going through each coin one by one, and the column I'm only starting from the given coin value to the sum. So in case of 1, it's going to start with 1 to 6. So the way we're calculating the different combination is, so in case of 1, so when you say 1 minus the current value, the current coin value minus the coin value. So it's going to be 1 minus 1 is 0. So there's only one way you can get the value, is 1. So in case of 2, it's 2 minus 1, there's one way you can do it. So it's going to be, so again, so can you get a 2 minus 1? So from here, get there, it's going to be 1. So it's going to be, again, to get the total sum of 1 using just coin ones, you have to be 1, 1 is the different combination you can have. Let's do that. And in case of total sum, coin sum 3, how many 1 you would need to do that? You need probably 3 coins, so 1, 1, 1 is. And in case of 4, you need 4, 1, 2, 3, 4. And in case of 5, similarly, you need 5 coins, 1, 2, 3, 4, 5. And for 6, 1, 1, 1, 3, 4, 5, 6. Now the fun bit is, using coin 2, how many coins you need, how many different combinations you need to get to. So again, I said I'm not going to start from 0 or 1, because I said I'll start with the coin values, which is 2. So we're going to start with 2. So for 2, so 2 minus 2 is 0. So you already have 1, so just say 1. So 1 coin only, which is 2. Moving on to 3. 3 minus 2 is 1, and we have nothing in, so you just skip that 3. For 4, 4 minus 2, the coin value, so you get 2. So you only have one way of doing it is 2. You add 2 more, because that's 2. Again for 5, 5 minus 2 is 3, and 3 cell is empty, so you can't do anything. Going back to 6, 6 minus 2 is 4. So you already have 2, 2, you have another 2 to make it 6. So that's, and then you start with 4. So again, I'm going to skip 1, 2, and 3, and straight away move to 4. So 4 minus 4 is 0. So that means you have only 1. So just put 1. How about 5? And sorry, I missed one bit, one information here, very important. So in case of 6, 6 minus 4 is 2. 6 minus 2 is 4, which is this. So we have two different ways. It's 4 ones and 2 fours. So the first option is going to be 4 1 and then 2 and then 2 2 2 and 2. So these are the two different ways using 4 and 1 and 2. And in case of 4, 5, there is nothing, because 5 minus 4 is 1 and 1 is empty, so you can't do anything. Now 6 minus 4 is 2, which is 6 minus 4 is 2, and we already have 1 1 and 2. So what I'm going to do is, so 1 1 4 and then 2 and 4, 2 and 4. So how many ways I've got? So did I miss something? Yes. So this got 1 2 3 4, says 5. I must have missed something. Let me check. 4 6 got solutions of 6. 1 1 4. 6 minus 4 is 2. 2 has, and for 2 minus 0 is what am I doing here? Is correct? 4. 4 plus 2 is 6. 2 plus 6. 1 1 4 is 6. 2 4 6. So the existing solution says 6, and I'm missing 1 here. So to get 6, I have one solution here, and then with using 1 and 2, I can do 1 1 4. 6 minus 4 got 2. This has 2. To get 2, to get 4, 6 minus 2 is 4, is 2 2. 4 minus 2 is 2. It's got 1. Oh yes, I missed 1. So it's going to be 1 1 2 comma. I missed 1 here, because when I'm calculating 4, total sum of 4 with using 1 and 2, so 4 minus 2 is 2. This cell, so it's got 1 1 and 2, so I have to add both 1 1 adding 2 and then 2 adding 2. So that's why. So then this become using 4, so 6 minus 2 is 4. Then this become 1 1 2. Then this become 1 1 2 2. 1 1 2 2. Then now I got 6. Yeah, that's the right combination. So let's solve this question with this. So difference is, when I'm trying to figure out how many different combinations is, you take the current sum value minus the coin value that I'm interested in, and if it is 0 you add that coin only once, otherwise you take whatever is the value. So if the difference is 0, you just take the first coin. So I'm going to first figure out the difference. So it says minus difference is the current sum value minus the coin value, and if the difference is 0, so what I'm going to do is I'm pushing to my combinations of the sum for this sum, for this sum, current sum, this coin, same coin. Thus, in case it's not 0, then I'm trying to figure out, because sometimes for given sum you may not have anything at all. So like in this case, in these two cells you have nothing. So this cell has got nothing in there. So I have to consider that case in case if the cell is empty. So so what I'm going to check is if exist combinations of that sum, difference, if the difference sum exists, then I'm interested in doing anything. And also I'm going to put another condition just in case. So that should exist, and there has to be some value, because it does exist but there is no value. So I'll just make sure, double sure you have value as well. So combinations $diff, otherwise I'm not interested. Is something? Yes. Bracket missing. Yes. Okay, so let's tidy up. So what I'm interested in, so in this case I will go through each of this entry. For example, this entry 111 41 112 22, and then I, using these three entry, I create these three by adding the coin value at the end. So I'll go through each of this combination for the given cell. So it says for each my, they call it coin, and I'll say dollar combinations diff, and I'm going to push. So I'm pushing these three values. Push at dollar combinations dollar diff. So this time I'm pushing value to this, not diff, but this current sum. So it's going to be S. What I'm pushing, so I'm pushing the different combination. So it's going to be, let's call it as printf. I'll use percentage S semicolon percentage D, and what this S is going to be the current coin, comma, and the current value, the existing value. So dollar underscore C is going to be this value, and this value, and then I'm adding them to the dollar C is going to be the row I'm calculating this value for. So that is printf is done, semicolon, and then save. So I'm going to keep adding that until on end there. So now, once I've gone through every row, so I'm only interested in, so I'm going to return, say return join /n, and interested in the combinations of my required sum. The sum is $sum. It's going to be $sum. So that is my different combinations. So I hope there's no typo in my solution. So let's run this again. So it does show me now the different combination. It's got 1, 2, 3, 4, 5, and 6. So these are the possible combinations I can think of. So let's try the different examples. So if I say I have maybe 10, 20, and say 50 coins, and I want a total of 80. So these are possible way of doing things. So 1, 2, 3, 4, 5, 6, 7 different ways I can achieve this. And so I hope this new solution would answer the question. So it doesn't just give the count, but actually the different combination as well. I like this approach better than what I had before. This is more clear to me. Maybe you probably have to go through one more time. So basically what you're doing is you go through each coin and then you process through sum from 1 to the total sum you're after, which is 6 in this case. And then you go through and then you take away the current column minus the coin value, go back to that column, and whatever is there, just add that, whatever the value is, you add the current coin to that list, and that's how you get the value for that column. And once you have it, then these are the ways you can do the different combination to get the sum 6. That's you get it. I hope this is clear. Thank you for watching this video. I hope you like it.